All right, ladies and gentlemen, let's talk about some square roots here, shall we? Let's go over some of the quizzes we just have done recent. Let's go over some of the quizzes we've done here in recent history, right? So the first thing is it says, what does this mean, square root of a? Well, the way you say it is square root of a, but what it really means is a number squared. This is a number squared that equals a. That's what it means. Another way you could think about it is you could think what squared equals a. You could say it as a question, but yeah, so what number squared equals a? Or what times itself is a, or, yeah. So then the second one is it says if the square root of a equals k cubed, um, what does k to the sixth equal? All right, well, so check this out. Would you guys agree if I made this observation? Was that true? Would you guys see what I mean? Now, of course, right? Because k cubed squared is k to the sixth, and we know what this equals right here. We know that that equals the square root of a, so that would be the same as this. You see? And the square root of a squared is just a. So there we go. Boom, done. All right, next up it says to simplify the square root. So it says to simplify the square root of x to the fourth times y. X to the fourth times y. So we're looking for something squared. We're looking for some number squared that equals x to the fourth y. That's what square roots mean. What squared is the radicand? And the way we simplify that is we look for factors of this that are perfect squares. So if we look at the factors of x to the fourth times y, well, this is x squared squared, isn't it? Right? This is x squared squared. So the square root of x to the fourth is x squared. So just this right here, just this part is equal to that. And the square root of y, well, that's not something we can simplify. The square root of y, well, we don't know anything about that. So this is the deal. X to the fourth times y equals x squared square root y. Now, the reason I know that's true is because if I square this, I get x to the fourth y. See, watch. Everything in here gets squared. So x squared squared, and then the square root of y squared. Well, that's x to the fourth, and that's y. Boom, done. See? All right. I know that one of the things that people are having difficulty with is they're trying to write down all these steps, and they're not really listening. They're not getting the idea. This and this tell you the ideas. And everything we're going to do with square roots is basically related to one of those things. All right, so now let's do square root of 96, 96. So what we need to do is we need to factor 96 and look for the largest perfect square. A lot of the time people do prime factorization, and I would suggest that that is a bad idea because prime factorization doesn't really address what square roots are. So I would say don't do that. It might help you get the right answer for a square root that's pretty simple, but it won't help you when we start doing cube roots, or when we start doing other roots, or especially when we start doing something like, rational exponents, like 16 to the power of 2/3. So you got to be a little more sophisticated than just breaking it all the way down. So we need to factor 96 and find the largest square number. So 96 itself is not a square number, but 1 goes into it. 2 goes in, I think, 48 times, right? Now I know 48 has a square number in it that's 16. Does 3 go in? 9 plus 6? Let's see. It goes in 32 times. 4 doesn't go in. 5 doesn't go in. Does 4 go in? 4 does go in. 24 times, I think. 5 doesn't go in. Does 6 go in? It does go in 16 times. Oh, look at that. Right there. That's the largest perfect square. The reason I know that's the largest perfect square is because this is 2 times 3 times 16. So here's what we got. We've got this fact right here. The square root of 96, well, that's going to be equal to the square root of 16 times the square root of 6. This number right here says, hey, what number times itself is 6? Well, that's the square root of 6. We don't know. It's irrational. But what number times itself is 16? Well, that's 4. Boom, done. Now, if we wanted to check it, we could. If this equals 96, we're good to go. So 4 squared is 16. The square root of 6 squared is 6. 96. Boom shakalaka. Man, this is like epic hotness right here. I don't even know what to do. Okay, simplify the following. It says square root of 3 divided by square root of 8. Well, the square root of 8 can be simplified. The square root of 8 can be simplified. The square root of 3, still the square root of 3. Square root of 8, well, that's 2 root 2. We've done that one a bunch of times. Look, 8 is 4 times 2. The square root of 8 then is the square root of 4 times the square root of 2. Square root of 4 is 2. Square root of 2 left over. Boom, done. All right, now, this is an irrational denominator. We need to rationalize it. So we're going to multiply by the square root of 2 over the square root of 2, because the square root of 2 times the square root of 2 is just 2. So these two right here, they make just 2. Times the other 2 is 4. And then that makes the square root of 6. That cannot be reduced because this is irrational and that is rational. So you can't divide them. All right, next up, square root of, oh man, the square root of m to the power of 4. Well, that's m squared. This is saying, hey, what's squared is m to the power of 4? That's what it says. Well, isn't the answer to that question m squared? So that's the question, and the answer is m squared. All right. Onward and upward to greater and more wonderful things. All right, so 3 root 8 plus 4 root 12 minus the square root of 27, 27, however you want to say it. Okay, with these, if these square roots, if these radical expressions are the same, we can add or subtract them. These are all different right now, but they can all be simplified. So what we need to do is we need to simplify them and see if there's anything similar. We know that the square root of 8 is 2 root 2. 2 times 3 is 6. We know that this is 2 root 3, right? Because that's 4 times 3. The square root of 4 is 2. 27 is 3 root 3. 8 minus 3, 5. Boom, done. Man, this is fantastic. Okay, the next one says to simplify the square root of k cubed squared. Well, that's k cubed. Now, here's one of the things you might not know. The square root of a, this square root is an exponent. That's the same as a to the power of 1/2. Very, very true. Very, very true. And so one of the things we're going to see, like if you were going to talk about the square root of k cubed, well, that's k cubed to the power of 1/2. And with exponents, when you raise a power to a power, don't you multiply them? Oh, wow. So that's just this part right here. And if that was squared, well, that's 2 over 1. Don't you multiply those again? You get k cubed. Whoa. Fancy that. Increíble. All right, next up, Buttercup. It says 5 root 2 divided by 3 root 8. Well, we can reduce those. You see, it's this whole thing again. These are the same. Sometimes, oh man, sorry about that. You couldn't see it. Sometimes this makes more sense than this. Sometimes this makes more sense than this. So you can switch them. You can change it however you want. And the thing is that you can reduce those. So this is 5 over 3 root 4. 8, 2/8 is the same as 1/4. So the square root of 2/8 is the same as the square root of 1/4. The square root of 1 is 1. The square root of 4 is 2. There we go. Man, this is fancy. All right. Square root of 4/7. Now here's a situation where we might want to separate them. Ah, yeah. Square root of 4 is 2. This is not a rational denominator, so we have to fix that, right? So we have 2 root 7 over 7. And that's it. Done. All right, and that is all she wrote, folks. Man, look at that. doggy. All right. Hope you guys, hope this helps you. If you have questions, let me know. I'd be very happy to hear from you. I hope you guys are having a wonderful day. Until next time, be safe.